So we have here a bearing. Now, when we read this, students, I want you to be very cognizant of the language that you're going to use, okay? You gotta be very particular about how you talk when you're talking about bearings. So in this case, I would say this is a bearing, or 130 degrees is the bearing of A from O. Okay, listen to that carefully. 130 degrees is the bearing of A from O. Now, the from O means this is my starting point. Of A means that's my end point. That's where I'm headed. How did I reach there? I was on a bearing of 130 degrees. Got it, guys? Does somebody want to give it a shot to read that? Let me see if I can full screen it. Go ahead.
130 degrees of E.
Very from O. Very good. So let me say it again. You got it. Like you got, like, I would say 95% of the sentence. You had it. So, but you got the main points, which is of A from O, and that's very, very important. Okay, so I'm gonna help you. 130 degrees is the bearing of A from O. So you just missed out is the bearing, which is very small. Okay, so let's continue. So here he's trying to find the bearing. Well, his goal, guys, is to find, he's saying that, let's say a plane traveled from O to A, okay? Plane traveled along this path, and this is an airport here. A is an airport. But now the airplane wants to go back to its original starting point. And so the point of this problem is we want to find the bearing of O from A. You see this? See the language? That's what we want to find. The bearing of O from A. So that's his goal. That's this math teacher's goal right now. So let's follow him along and see what he's gonna try, what he's gonna do. Okay, so he starts off. Okay, he's talking here. And he's gonna do something very specific to that A point. He's gonna give it a north, because that's the only way we can find the bearing. We have to apply the north. And he's being very careful, students, to make sure that this line is parallel to this one, to this original north line. Both these have to be parallel, because once they're parallel, we can do mathematics. Okay? Once we have those two parallel lines, we can do some math. And you'll see what I mean as we go along. And so he's given the A cardinal points, and specifically the north. He doesn't really concern himself with putting an E and an S and a W. So please, you don't need to do that, okay? You don't have to put an E here or S there or a W. Just focus on the N, the north. All right, now remember, we want to turn our plane around. What's the bearing that would send my plane back to O? So we want to find the bearing of O from A. So let's do that. So he's going along, and now he is showing you, this is what I have to do. I have to start from north and go in a clockwise direction. That's what he did. Okay, and now he's trying to figure out, how can I find the bearing with the information I have? So he says to himself, you see this point right here, this angle that hasn't been captured by the blue marker? Well, this angle right here, if I knew it, I definitely can find this bearing. How could he do that, guys? What is so special about this point right here? Can anybody explain why he would feel confident? Like, if I knew this, I'll know everything. Can anybody tell me why? Why would that be an important angle to find? Well, do we know what the total rotation is? The total amount of angles in a circle? What are the total amount of angles or about a point in a circle? What's the total? Anybody remember? You guys can hear me? You still there?
Yes, sir.
Okay, just checking because it's kind of quiet. My tech classes were never this quiet.
You could hear me, sir?
Yeah, I could hear you. So why would I need to find this little angle right here? Oh, the question was, what's the total angles in a circle?
360, sir.
Very good. And why would finding this angle help me to figure out the bearing?
Sir, because if you find that angle, then you could subtract it from 360.
Very good. And so that's the main point of this exercise here, is to find this angle. And so now I'm going to tell you something. Because we have two parallel lines here, and this is called a transversal, a line that cuts across two parallel lines is called a transversal. What happens is that this transversal formed what is called interior angles. Notice that. Notice this little angle right here. These are called interior angles. And what we know about interior angles is when you add them together, you get 180. So that information right there, it could tell you what this angle is. Interior angles must always add up to 180. So what is this angle? Anybody? If interior angles always equal 180, then what's this angle?
50, sir.
That's correct. All right. So that is one way to find the answer. Another way is what our math teacher will show us. He's going to show us a different way, an alternate way of finding this angle here. Okay, and I gave away the method he's going to use. Okay, so let's continue. So he's going along. He has a lot of great things to say, and he has a Australian accent. So when you look at this video in Moodle, you get to hear his accent. Right? It's not a common accent we have here. All right, so he put a dot at that angle because that's his goal. Man, if I could just get that angle, I'm done. You know, he wants to go and drink coffee or something. I'm not into that, but you know, a lot of teachers are into coffee. All right, so he's going along saying, I need that angle. Aye, mate. I can't do the Australian accent. Anyways, notice what he did here. He has put dots in an alternate fashion. Now we are familiar with this because we just finished some assignments called angles of elevation and depression that required us to know about alternate angles. We know that alternate angles are equal. So if I know this angle here, then I'll know what this is. So how can I find this angle? Well, we know that the total angles of a straight line, anybody know that by heart? What's the angles of a straight line or the straight angle? What's the degrees of that? What's the degrees of the straight angle? Anybody? Anybody? The degrees of a straight angle? You guys know the degrees of a right angle.
180, sir.
Ah, okay. The degrees of a straight angle is 180. Very good. And the right angle of, is 90. All right. But yes, 180. So we know that if I subtract 130 from 180, I'll have this number. And you will get the number. What will that number be, guys?
50, sir.
50.
50.
Yes. And you notice it forms a Z. So this is to look for the Z whenever you're doing some difficult, complicated trig problems with bearings. Always look for that Z or look for those interior angles. And now students, if this is 50, then we know what the other dot is. Okay, so let's keep pushing this video forward. Okay, so for those who just joined, welcome. We are looking at bearings. We are looking at reading this carefully. We always start from the north in a clockwise direction. Right now we have the bearing of 130 degrees, and the way to read it is 130 degrees is the bearing of A from O. But now what we're looking for here is the bearing of O from A, because A is my starting point. So you got a little bit of his accent if you were able to hear that. All right, so we're moving along. We figured out that this angle right here is going to be equal to this angle because of something called alternate angles. So look for the possibility of that. That's a very nice method of getting your missing angle using alternate angles. Or you can use interior angles where you add up the interior angles, which always equal 180, and you still get your 50 here. So let's keep moving. Let's see what he does. Oh, he's going to do some math for us. Great. Because I want to see working. I don't just want you to put an answer there. Okay, so let's move it along. Okay, so he puts his 180, right? Puts his 180. And now he's going to subtract. He should subtract 130. And notice he creates his own little algebraic symbol. That you can read that as the angle of the dot. You can read it like that. And the angle of the dot equals 50 degrees. And so now we know this is we can form an alternate angle, and alternate angles are equal. Therefore, so he's going to write his reason for putting that 50 there. He didn't just put a 50, he had a reason for it. And that's what mathematics is about. It's about helping you to be critical in your thinking, where you have a reason, a good reason for the things you do, okay? We don't just want to put a number there and say, well, I felt like that goes there. My feelings told me to put that there. Okay, that's for another subject, but not for math. And so here we have, he's telling us, oh, you could use that interior angle method to find 50 as well. And I already explained to you how that works. You just add up the interior angles and they should equal 180. And if you add 50 to 130, you do get 180. So here we're going to continue. And he's going to talk about the revolution. Total revolution is 360. But we have here 50, therefore we must, as Malcolm mentioned, subtract. So we're going to subtract there. I don't know if this is something they do in Australia, but looks like they put the subtraction sign way over there. So it's a different convention than what we're used to here. But we get the same answer, 310 degrees. Now, would anybody like to attempt to read this bearing? So the bearing, we want to read the 310 degrees is the bearing of, all right, and then you just finish that sentence, guys.
So 310 degrees is the bearing of A.
O, the O,
Of
O.
Of O from
Yeah.
A.
From A, very good.